In this video, we're going to connect solving quadratic equations with the graph. And so what I've done is I've graphed this function right over here to the right here. And what we want to examine is what's going on in this. So really, when we've solved these quadratic functions, what we've done is we've substituted 0 in for y, and we've been trying to find the x values that go with that. So this question is really what we've been solving. And so we've substituted 0 in for y, and I show that down on my table. So 0 is in for y, and we're trying to find the x values that go with that. So if I do that, and then I can try to factor this portion to find the x values that make this true. And when I do, I get x plus 6 and x plus 7. And then when I find the solutions to this, I would say x equals -6 and x equals -7. And where I want to point that to now is what that looks like on a graph. So we substituted 0 again in for y, and we found that the x value could be -6 or the x value could be -7. So this is really what our table looks like. And on the graph, here is a point that is -7, 0, and then here is a point that is -6, 0. So really what we're doing is we're substituting 0 in for y, finding the x values that go with it to find 2 points. And these points are in fact the x-intercepts, which are also sometimes called the roots or the zeros. So if it asks you to find roots or zeros, this would be the same process it would be looking at. So this one has 2 solutions, 2 roots, 2 zeros, 2 x-intercepts. And those intercepts are -7, 0 and -6, 0. And the graph agrees with that. Here's another similar problem. If we substitute 0 in for y here, and we're asked to solve it, we substitute 0 in for y, and now we're trying to figure out the x values that go with it. So in this case, we would factor a greatest common factor of 5x, and then we would have x plus 5. And really what we'd be finding here is that x equals 0 and x equals -5. So when y was 0, these were the values for x that made it true. So taking that to the table, we have these 2 points. And if we look at the graph here of this function, which I've graphed to the right here, those are the 2 values. So 0, 0 is a solution, and -5, 0 is a solution. So making the connection that really when we're solving these quadratics, when we're solving a problem that looks like this, really what that happened beforehand was that a 0 is substituted in for y, and we're finding the values that go with it. And so looking at this, we should be able to identify the zeros, the roots, from a function given like this. So that's really what we're trying to do, and we always want to connect it back to the graph.